Hello, differential equation students, and welcome back to 7.6, and this is going to be video number 2. Okay, and we're going to be showing our second example. And what we did on the last ones is we're trying to solve differential equations, a system of them, using Laplace transformations. So the first thing I want to do is I want to take the Laplace transform of each of these, which would be s squared big X minus s x at 0 minus x prime of 0 plus s squared big Y minus sy of 0 minus y prime of 0 equals 1 over s minus 3. That was this one right here. Doing the next one, I would have 3 times s of big X minus x of 0. Then I have the same y prime here, so it's s plus s squared big Y minus s times y of 0 minus y prime of 0 equals 2 over s minus 3. Right? And at first it might look a little much, but what's really nice here is that I have all these zeros. So like this is a 0, 0, 0, 0, 0, 0, and a 0. So really what I end up having on the top equation is s squared big X plus s squared y equals 1 over s minus 3. And on the bottom I have a 3s big X plus s squared y equals 2 over s minus 3. Okay, and when I take a look at this, right, and I see the fact that these already match exactly, that means I just have to take this equation and I subtract it from the other one, which would give me s squared minus 3s. That's this portion here, and it has an x. These ones go away. Then I have 1 minus 2, right, because plus a negative here, which would give me a negative 1 over s minus 3. A little bit of math here. I have big X then is equal to a negative 1 over s times s minus 3 squared. Of course, I'm factoring this and dragging it over. Okay. Now looking at it, I have what x is, big X is, according to just s's, right? And I boxed this here because it's going to be super important for me to use here in a little bit, because I'm going to use it twice. Okay, so here I have x basically ready. We've seen this stuff before. Now this is where I'd break it down, right? I have a this thing should be equal to my a over s plus b over s minus 3 plus c over s minus 3 squared, right? And once I get that, right, don't forget that this still is equal to negative 1 over s times s minus 3 squared. And this creates the auxiliary equation, right? Negative 1 equals a times s minus 3 squared plus b times s minus 3 plus c times s, which, looking at it, if I let s equal this 3, that would imply that negative 1 equals, well, this is gone, so I'd have just a 3c, which makes c equal to 1/3, right? And, oh, I'm sorry, negative 1/3. And s equals 0 then gives me negative 1. Well, this would create a 9a. Gone, gone. So that implies that a is equal to negative 1/9. Here I see that a would have an s squared. What else would? Well, there's no s squared over here, so it's a 0. There's a with an s squared up here. This b will also have an s squared, but the c won't. Which means that if a was negative 1/9, then b has to be 1/9. Okay. Which again, breaking this down then, I would have a negative 1/9 times 1 over s plus 1/9 times 1 over s minus 3 minus 1/3 times 1 over s minus 3 squared, which gives me, if I take the inverse Laplace, that would be a negative 1/9 plus 1/9 e to the 3t minus 1/3. Okay, this is squared, so I know that this is usually a t. S minus 3 in the bottom means that this is e to the 3t. And I have my x equation, right? Got my x equation. And we did it decently fast, about 6 minutes or so, with me talking, right? So now here's the trick. I could do what I did last time, but if I do what I did on the previous examples and plug it in, I have these y double primes, which are going to give me a lot of trouble. Because I have to integrate twice, right? To undo y double prime, I'd have to integrate and then integrate again. I don't really want to do that. You can do that. It's definitely a method. Instead, what I do is I look up here in these equations, and which auxiliary equation up here seems like it'd be easy to work with. Well, when I look at it, I'm thinking that this one right here seems to be decently easy. Okay, so if I pull that out over here, I have s squared x plus s squared y. It's a terrible line. Okay, equals 1 over s minus 3. Well, I know what x is. It's right down here, right? I know that my x is down here, and I can put it in right here. So when I write it out, I have negative 1 over s times s minus 3 squared. Now this whole thing times the other stuff that I'll build around it. So I have this s squared, drop it down. And I have plus s squared y equals 1 over s minus 3. Okay. And now here, you know, I just have to do a little bit of math. Like I see this s squared here. How would I get rid of that s squared? Well, you would multiply, or you divide here by s squared, which means I have to divide here by s squared, which again means that this down here would get an s squared. And what would be left? Well, it'd just be this thing, right? So I'd have y, if I move this thing over simultaneously, I have a y equals 1 over s times s minus 3 squared plus 1 over s squared s minus 3. Okay. The nice thing about this, okay, is I've actually already done, here, let me highlight it so you can see. I've already figured out what this thing is, right? Because it's my x down here. Like I already have my a, b, and my c. I already have these. I already have all those. So I actually already know how that one breaks down. In fact, I already know all the inverse Laplaces. I would just be this x value. So really all I need to work on is this s squared, this section right here. Which, I mean, you can do it a couple different ways here. I think I'll just make this a over s plus b over s squared plus c over s minus 3, which then gives me 1 should equal a s minus 3 plus b s minus 3 plus c s squared. I let s equals 0, and 1 would equal what, negative 3b. So b would be equal to a negative 1/3. If I let s equal 3, well then this a goes away, this b goes away, but the c's there. So I'd have 1 equals 9c, which means that c is equal to 1/9. And finally, looking at this, I would have to break down this, well, the problem in general, really. When you see I have, what, C and B already done, I need A. A will have an S squared. Well, there are no S squareds here, so it's a 0 equals A. What else will have an S squared? Not this B, but the C does. So I already know that C is 1/9. If these added together get 0, this has got to be a negative 1/9. Okay. Which then, I now know that this little section, right, this little section here has become a negative 1/9 for my A, which was times 1 over S. B was negative 1/3 times 1 over S squared. And then C was 1/9, and that was times 1 over S minus 3. Okay, which when I take the inverse Laplace of that, I'll have a negative 1/9 minus 1/3, and that's a t, plus that's 1/9 e to the 3t. Now this is not the end answer. This section is only this one here, right? It's only this little piece, which means I have to add it into the x stuff. Well, the x stuff is right down here, right? So maybe I can drag this and get it a little closer so I can see it. Oh. Right? So now when I create the y, all I have to do get the right color here. Okay, all I have to do is combine some stuff. So one thing to keep in mind is that this right here is a positive 1, but down here it was a negative, which means that these signs are all opposite. So it's like this is a negative or a positive 1/9, this is a negative 1/9 e to the 3t, this is a positive 1/3 t e to the 3t, and then I have minus 1/9 from here, minus 1/3 t minus or plus 1/9 e to the 3t, which, doing a little bit of combining here now, well, these go away. That's nice. Do I have any other just 3t's? Yes, I do right here. These go away. I have a negative 1/3 t, which doesn't seem to be going anywhere. And then I have a plus 1/3 t e to the 3t, and that is my y of t. Then I have my two equations. Now, there was a different way that you could have done it. Like I said, here we could have found x prime and then x double prime, and we could have plugged those in up here. The problem, remember though, is you'd have to take this double integral of y double prime, and you're going to end up with constants that you're going to have to reuse these initial values to get rid of. Okay, can definitely be done. It is a little bit more time consuming. The other thing is, right here when I got this y piece, okay, I hate to do this, but I'm going to erase some of my work here. Right here, I try to clean this up just a little bit. Oh, and I definitely took too much there. That's okay, I can rewrite it. Okay, here, when I'm thinking about it, I essentially got big Y to equal 1 over s times s minus 3 squared plus 1 over s squared times s minus 3. Here I also could have tried to combine these two. I see that this one has an s minus 3, this one has s minus 3 squared, so I know that I would have to add in or multiply the bottom over here by s minus 3, and then do that also to the top. This one here has an s squared, so I need another s here, which would create a top of s plus s minus 3, which would be 2s squared, or I'm sorry, not squared, 2s minus 3, and that would be all over s squared times s minus 3 squared. And after that, I could just break it, right? This is big Y, and then I could make this become a over s plus b over s squared plus c over s minus 3 plus d over s minus 3 squared. Okay, and then I could find a, b, and c and work it backwards from there, and I should get the exact same answer as I did down here. Okay, and that completes the second problem over 7.6.